Welcome to the Explainer. Today, we are diving deep into the Linux kernel to explore the invisible scaffolding that holds the entire device model together. That's right, we're talking about Kobjects, Ksets, and Ktypes, the core building blocks that manage, well, basically every piece of hardware you've got.
And, this quote from kernel maintainer Greg Crowe-Hartman absolutely nails it. See, a core object isn't something you really use by itself. Its whole purpose is to be the fundamental piece, kind of like a single atom, that's used to build up and organize the thousands of devices and drivers in a Linux system.
So here's our game plan. First, we're going to look at the problem that started all of this. Then we'll break down the solution piece by piece, Kobjects, Ktypes, and Ksets. And finally, we'll put it all together and see why any of this actually matters to you. Okay, so before the Linux 2.6 kernel, things were messy. It was kind of the Wild West. Every different type of bus had its own special way of keeping track of devices. What they needed was a unified driver model, one single, consistent way to handle everything. And at the very heart of that new model, you guessed it, the K-object. So let's start with that most fundamental piece. Just think of a K-object as a single Lego brick. I mean it. By itself, it's not much to look at, but it's the standard, reusable part that you absolutely need to build all the bigger, more complicated stuff. So a K-object on its own, well, it doesn't do a whole lot. Its real magic, its superpower, comes when you embed it inside other data structures. The moment you do that, your structure gets two critical abilities for free. First, lifecycle management through reference counting, and second, a way to show up in the /sys file system, which is how the kernel tells the rest of your system about all the hardware it's found. And let me be perfectly clear, the kernel documentation is not messing around with this one. This is the golden rule. If you stick more than one K-object into a single structure, you are going to have a bad time. You'll totally wreck the reference counting, which leads to all sorts of nasty bugs. So yeah, don't do it. So this whole reference counting thing is actually pretty elegant. Anytime some code needs to use an object, it calls kobject_get. That's like saying, hey, I'm using this, don't delete it, and it bumps a counter up by 1. When it's done, it calls kobject_put, which is like saying, okay, I'm finished, and the counter goes down. Once that very last user is done and the counter hits 0, the kernel knows it's finally safe to free that object. Simple, right? All right, so a K-object is a great little bean counter. It knows when its time is up, but it has a problem. When that reference count hits 0, the K-object itself has absolutely no idea how to clean up the larger structure it's living inside. For that, it needs an instruction manual, and in the kernel, that's called a Ktype. You can see the difference pretty clearly here. A Kobject on its own knows when its life is over, but it doesn't know how to clean everything up. The Ktype provides that one missing piece. It's called a release method, and that's basically a pointer to a function, the how to destroy me guide for the whole object. And yep, this is another one of those non-negotiable rules. You simply can't have a Kobject without a defined plan for how it gets destroyed. That plan is the release method in its Ktype. If you forget it, or just leave it blank, you've written a bug. Plain and simple. Okay, so we've got our individual Lego bricks, the Kobjects, and we have their instruction manuals, the Ktypes. So what's the next logical step? Well, you group them all together into a proper Lego set, right? In the kernel, that's the job of the Kset. A Kset is basically a container for a bunch of related Kobjects. A perfect example is a hard disk. The disk itself might be one Kobject, and then every partition on that disk is its own Kobject. The Kset is what groups them all together, and it represents them as a single directory you can see in the /sys file system. But a Kset is so much more than just a boring list. It's an active manager. It's what actually creates that directory in sysfs and organizes all its Kobjects. But crucially, it's also what helps the kernel handle hotplug events. Like when you plug in a USB drive, the Kset is what helps figure out that happened and how to tell the rest of the operating system about it. So why on earth should you care about all this internal kernel stuff? Well, because this whole invisible system is exactly how the kernel communicates hardware changes to the apps you use every day. It's the bridge that connects the super low-level kernel world to what you see on your screen. And this is where it all comes together. Check this out. When you unplug a device, its Kobject gets deleted. That one little action kicks off a whole chain reaction. The Kobject tells its Kset, the Kset adds some helpful info, and then it sends something called a U event, an update event, out to user space, which is where your apps live. Your desktop environment hears that message and knows, aha, I should remove that device's icon. Pretty cool, right? So the big takeaway here is that these three simple, layered ideas, Ktypes for counting, Ktypes for behavior, and Ksets for collections, all combine to create this incredibly robust and powerful system that manages every single piece of hardware in your machine.
You know, it's a great reminder that underneath a hugely complex system, like an operating system, there's often a really elegant, even beautiful design, making it all possible. It really makes you wonder, doesn't it? What other fundamental structures like this are hiding in plain sight? Thanks for joining me on this explainer.